The introduction topics are the following topics. We will first look at what event processing means. We will then introduce the Esper event processing software. After that we discuss the term event and what an event looks like. Next we will write "Hello World" code. We will discuss basic principles around streams, data windows and filter expressions. The section thereafter overviews the EPL event processing language. Finally we provide technology-related information. Let's discuss event processing. Businesses use data to identify new business opportunities, better serve customers, grow sales, improve operations and more. Businesses often need to detect complex situational scenarios and act on them. Acting on a detected scenario without delay, at the right time and with low latency is a business need for many organizations. It is also a technology challenge as a technology must handle fast-changing data and rich relationships between data. Researchers in the early 1990s called this field complex event processing. With complex, the researchers meant composite, rich situation detection with time and event causality. Event processing is also called event series analytics and streaming analytics. Event processing can also analyze historical data by replaying time and events. Event processing does not require streaming data. Event processing is a fundamental change. It changes the practice from analyzing data at rest to analyzing data in motion. Data at rest lives in a database of some kind. Applications have to store the data in the database before it can be queried. Applications often store a lot of data in a database. Applications generally query the database using SQL or an application call in a request and response. But databases are often not suitable for time-based analysis. Also, databases don't allow write-time low-latency analysis. Think of tipping the database upside down. Now, instead, we analyze data in motion using event processing. Event processing stores the query and handles the data as it arrives. The EPL event processing language is designed to analyze the data in motion. Instead of request and response, event processing uses subscribe and notify. Event processing does time-based analysis, expresses causality and detects in write-time low latency. EPL is a continuous query language. Continuous queries analyze new data as it arrives. Event processing knowledge and technology have been around for a while. Simple event processing includes routing events, filtering events and enriching events. Some technologies that provided this kind of functionality are Java messaging system and enterprise service buses. These kind of technologies are stateless. Stateless means there is no stored knowledge of past events or other past data. The simple event processing technologies also don't offer time-based analysis. Some applications required computing moving aggregations over a subset of events. Early event stream processing systems evolved that kept state such as sums and averages, and that allowed some time-based analysis. This kind of processing is stateful, meaning there is stored knowledge of past events or other past data. Requirements evolved and business needed event processing with rich situation detection. A situation may span many event streams. A situation may have causality rules such as, for example, event A followed by event B within T minutes. A situation may have varied event, time and situation relationships. A situation may combine historical and real-time data. We developed Esper to satisfy these requirements. Esper offers stateful processing and rich time-based analysis by providing the EPL event processing language. Event processing deals with a large number of generally small data points, events. Event processing processes the time dimension. Event processing is low-latency processing. Event processing is usually stateful. Event analysis can be sensitive to event order of arrival. The Esper EPL event processing language is a declarative programming language. EPL allows you to write short, efficient code. But, it may be hard to understand by external people that don't know the conceptual model. EPL allows for easy optimization as the implementation is controlled by Esper algorithms. But, it can be harder to understand the exact execution characteristics. EPL makes maintenance possible independent of application development. Other declarative languages include SQL, query, regular expressions, functional programming and configuration management systems. EPL integrates with imperative programming, code written in a programming language. Esper was started in year 2006. It is licensed under a GPL v2 license. There have been many new releases since inception. The source code of Esper is public at GitHub. The release notes that details all the changes between versions can be found in the changelog.txt file in the root folder of the repository. Esper is applicable to applications in any business domain. It was originally started from financial expertise and from the requirements of financial applications. Esper does event processing only. It is not designed to be used as a data store or an event broker. Esper is designed to be embeddable, capable of being used in any JVM. The EPL compiler only requires a parser and a Java compiler. The compiler can run independent of the runtime. The EPL runtime only requires a logging library. Esper consists of Java only and does not need any native library. EPL is designed for processing streams of events and time. EPL conforms to the SQL 92 standard. EPL offers data windows, aggregations, joins, subqueries, pattern matching and more. EPL is a continuous query language and provides streaming SQL. Since it is based on SQL standards, it is generally easier to learn. But, EPL itself is not a standard. Esper EPL is specific to Esper. SQL semantics are clearer compared to if-then rules syntax. Esper provides APIs for event processing. The compiler API compiles EPL text into bytecode. The runtime API deploys compiled EPL at runtime, by loading bytecode and optimizations for processing. The listener and subscriber API is for receiving results. An application sends events into the runtime for processing. There is a pull API that can be used to get current EPL results and to execute fire and forget queries. There is a EPL module and statement object model that represents EPL as Java objects so that application code can inspect or build EPL. Esper defines how events are represented. It provides name and type information and supports any type of object as an event property. This picture shows Esper as part of EsperTech's ecosystem of event processing technology. The light blue color is for open source. The other colors are for EsperTech's commercial closed source offering. In the middle is Esper, in light blue. On the top, in red, are Enterprise Edition services. On the bottom, in purple, is Esper High Availability. This picture is meant as an overview, and does not indicate scalability or required technologies. In the middle is Esper, in light blue. Events, and time, come in on the left side. The input is the runtime API and input adapters. The Esper runtime handles the processing of deployments, named windows and tables and patterns. On the right side are listeners, subscribers and output adapters that form the output side. The red boxes on top are provided by Enterprise Edition. Enterprise Edition provides a visualization and management web-based user interface. It also provides REST services and data push, and a JDBC API. The purple box on the bottom is Esper High Availability. Esper High Availability is a part of the Esper runtime that manages state resilience and high availability. This picture shows Esper horizontal scalability. Esper horizontal scalability requires Kafka and Kafka streams. A Kafka streams application consists of a cluster of Kafka brokers. The Kafka brokers assign partitions to the available application instances. Each application instance receives, through Kafka streams, the assignment of 0, 1 or many partitions. Each partition hosts a Kafka streams processor that is an Esper runtime. This allows your application to run multiple instances wherein Kafka brokers evenly distribute load to application instances by assigning partitions. The architecture allows for automatic discovery of available instances and routing of events and queries to responsible instances. When an application instance stops, Kafka reassigns responsibility for the partitions to the remaining application instances. When a new application instance becomes available, Kafka may rebalance. A rebalance means that Kafka deassigns one or more partitions from other application instances and assigns these partitions to the newly available application instance. Now we are discussing events and how they are represented in Esper. An event is a record of a past occurrence of an action or state change. Event properties capture the information that is available about the event. For instance, car arrives at a parking lot is an event. Event type name is the name assigned to a type of event. Let's call the event describing the car arrival a car arrival event. Event type includes the information about the event property names and property types. The example, car arrival event, has a location property of type string and a vehicle ID property of type string. Event representation is what kind of programming language object we use to represent an event. Esper provides choices for what object to use. An event object can be any Java object and can also be a map, an array, a JSON document or a XML document. Note: event objects are immutable. Since events are observation about the past, they are not meant to be modifiable. All event representations allow event property types to be any Java object type. Esper allows you to choose the best way to represent an event as a programming language object. We will go over the different event representations next. Esper allows any Java object to become an event. Use the send event bean method and pass the object and the event type name. Object graphs are a convenient way to handle nested, composite or repetitive data. Esper also allows inheritance and polymorphism. Esper allows a map to become an event. Use the send event map method and pass the map and the event type name. Maps can be nested and can contain any Java object. Esper allows an object array instance to become an event. Use the send event object array method and pass the array and the event type name. Arrays can be nested and can contain any Java object. Esper allows a JSON string to become an event. Use the send event JSON method and pass the JSON and the event type name. Esper allows a XML document to become an event. Use the send event XML DOM method and pass the document and the event type name. Esper allows an Avro record to become an event. Use the send event Avro method and pass the Avro and the event type name. Event properties contain information about the event. Event properties may themselves have nested information, or repetitive information, or information that is kept in a map. This slide assumes there is a sensor event that has event properties like a sensor identifier, manufacturer, temperature and switch status. You can specify the event property name in an expression. This returns the event property value for that name. For example, sensor ID, to return the value of the sensor identifier. Let's talk about nested properties. When the event property type is itself an event or any Java object, you can use dot to navigate the composition. For instance, sensor.manufacturer.id to return the value of the manufacturer identifier that resides within the manufacturer property that resides within the sensor event. Let's talk about indexed properties. When the event property type is repeated, like in an array or a collection, you can use square brackets to index into the repeated values, such as temperature bracket 0 bracket, to return the first temperature value within the sensor event. Let's talk about map properties. When the event property type is a mapping, you can use parenthesis and provide a key string to access a map value. To illustrate, switch status parenthesis quote light quote, to return the switch status for the key quote light quote. Let's talk about dynamic properties. When the event property is not known, you can use question mark. The runtime returns a null value if the event property is not found. The type of a dynamic property is always the base object type. One example is sensor location question mark. For dynamic properties, if the runtime finds a property by that name for a given event, it returns the event property value and otherwise returns a null value. Note: the EPL compiler validates that the event property exists, except for dynamic properties, and there is a compiler error if it does not exist. This slide lists the general steps to take for a Hello World application. Note: this code is incomplete. It cannot be cut and pasted. Not all the code is shown here. First, decide what the event looks like. Here, since this is just an example, we want to make the example as short as possible. We define a new empty class by name, Hello World Event. The second step is to compile and deploy EPL. The EPL we are going to compile is select from Hello World Event. The EPL compiler outputs a binary of type EP compiled. Next, deploy that binary to the runtime. The result is a EP statement that represents the deployed EPL. The third step is to attach a subscriber or listener to receive output. The runtime calls this listener to deliver results. Our subscriber code has an update method that receives the Hello World event and prints it to console. The last step is to send an event into the runtime. The code instantiates a Hello World event and invokes send event bean to process the event. Above steps can all be completed at runtime, while the application is running. Most applications would send many events and would repeat step 4.